tell me when you are ready. Okay, thank you. In this lesson, we are going to see how to do problems with percentage purity. Percentage purity is not new to you, you did it in grade 11, but today we are going to combine this with the titrations, with the acids and bases topic. Now let's read this question. In order to determine the percentage purity of calcium carbonate in seashells, seashells have got calcium carbonate. So someone wanted to find out what percentage of the seashell has got calcium carbonate. They want to find out the percentage of calcium carbonate in the seashell. So they took some amount of seashells and ground them into powder. What is the amount that they have taken? 5 grams. And then they know this one is a base. So if you want to find out, you have to make it to react with an acid. So what is the acid they have taken? Dilute hydrochloric acid. The learner has taken dilute hydrochloric acid. He did not know how much to add exactly. So because he's not doing titration, so he's just adding. So when he added, he just tried with 500. 500 centimeter cube of dilute hydrochloric acid. What was the concentration? 0.25. Now let's write that down. Number of moles of HCl initial. This is what he did. It's coming from the formula C times V. What is the concentration? 0.25. What is the volume? 0.5. When you do that, what is the number of moles of HCl in the beginning? 0.125 mole. So when we read this question, the mole, you will realize the mole ratio of acid to base. Acid is 2 and the base is 1. Then you see the word excess HCl. So it's very clear the HCl the learner has added is too much. So the excess HCl is titrated with 140 centimeter cube of sodium hydroxide. So what happened is the HCl, what the learner has added, has become too much, and he wanted to find out how much is excess. So what he did with that solution, he titrated with sodium hydroxide. So the number of moles of sodium hydroxide that reacted with the excess HCl is given there. So now we are going to write down the equation for NaOH and HCl. It has a mole ratio of 1:1. So if you know number of moles of NaOH, we also know the number of moles of HCl because the mole ratio is 1:1. Let's find out the number of moles of this sodium hydroxide. What is the ratio? The formula is C times V. What is the C here? 0.2. What is the volume here? 0.14. When you do the calculation, what do you get? 0.28 moles. That means the number of moles of HCl excess. How much was excess? We are doing it in terms of number of moles. You can also do it in terms of volume, but I am teaching you the method how to do it in terms of number of moles. So the number of moles of this one is 0.028 mole. That means amount of acid, the amount of acid that you added is 0.125. But now you find out how much was excess, 0.028. So what was the one that was reacted with your seashells? Let's find out number of moles of HCl reacted. What is the formula? Number of moles of HCl initial minus number of moles of HCl excess. Okay, so what is it? 0.125 minus 0.028. Let's do the calculation. 0.015. Let's do the calculation and see what do you get here. 0.125, 0.125 minus 0.028. Let's do the calculation. See what do we get here. 9.7. That means 0, okay, this is answer. You get 9.7 times 10 to the power of minus 2 moles. So we know how much HCl has reacted with our calcium carbonate. But our aim is to find out the mass of calcium carbonate. But what we know is the number of moles of HCl reacted. Now I am going to continue. What am I going to do? I am going to use the mole ratio of calcium carbonate to HCl. Calcium carbonate to HCl. This is the HCl that is reacted with your calcium carbonate. We got this. What is the ratio? If this is 1, this one is 2. What is the mole ratio of HCl? 9,7 times 10 to the power of minus 2. So you put x here and cross multiply, and when you do that you will get x is equal to 9,7 times 10 to the power of minus 2. You have to divide that by 2. Let's see what will happen. Divide by 2. What is it going to give you? 4,8. Okay, now what we have got is number of moles of calcium carbonate in your seashell. You have found out it's 4,85 times 10 to the power of minus 2 mole. Now what is the question? The question is about calculate the mass of calcium carbonate in the sample. To find the mass, we use the formula N is equal to mass over molar mass. This one is 4,85 times 10 to the power of minus 2. Mass, the molar mass for calcium carbonate is 100. When you multiply by 100, what do you get? Mass is going to become 4,85 grams. So that is a mass that is present in the 5 grams that you used 5 grams, but you don't have 5 grams of calcium carbonate. According to the chemical calculations and the procedure, we found out it has got only 4,85 grams. So the percentage is not, the chemical is not 100% pure. So now to find out the percentage purity is equal to mass of pure over mass of impure over 100 times 100. So which is 4,85 divided by 5 times 100. Let's do the calculation. See what do you get here? 4,85 divided by 100 and see what is the percentage. Okay, 4.85 divided by 5 equal to times 100. What is the percentage here? Which is 97%.